Okay, we're going to be looking today at copper. And this is something that, looking back in the old video, it's a short video and there isn't any experimentation in it, so I thought we'd do something a bit practical.
Copper is an element which people are very familiar with because it's such a characteristic coloured metal, sort of reddish colour, though it gets darker when oxide forms. But it's quite a soft metal and you can cut it quite easily. If you have a cutter like this that has steel blades, it will just dig in to the metal and it should just cut off. When you cut the metal, you get this very nice, shiny, fresh surface, coloured just like copper.
This is a ball of copper metal. It's quite, as you might imagine, it is a ball of metal in it, so therefore it is quite dense and heavy. I mean, it's not as dense as, I think Steve told me this morning, if we had a ball of this size of plutonium, he told me it would weigh about 1.5 kilos, so he thought. So it's not quite as heavy as that, but it's still pretty heavy and dense.
So this is a very, very, very nice sample of very fine copper wire. So the copper wire here is, what width is this? This is 0.0, I'm not going to, that's just too small. So it's 0.1 of a millimetre.
Okay, so inside the beaker we've got a solution called sodium potassium tartrate. So no copper in there at the moment. We're going to introduce that through this. This is a solution of copper sulfate.
Copper is very popular for architectural use because if you put it on the roofs of buildings, it then reacts particularly with carbon dioxide in the air to give a very nice green colour.
First of all though, we need to heat this to about 50 degrees C. And to the sodium potassium tartrate we need to add some very weak hydrogen peroxide. So this is only 3% hydrogen peroxide. So in it goes. We need to make sure they mix together, which is why there's a stirring bar at the bottom there stirring away.
Guess what? Look who's walked in.
Okay, so it's stirring nicely. So as I said, sodium potassium tartrate and hydrogen peroxide, and we need to add only 1 mil, so that's 1 centimetre cubed, of the copper sulfate.
So the copper wire here is very, very high grade. This is grade 1 copper wire, and it's 0.1 of a millimetre in diameter, and you can see the wonderful copperous lustre coming off the side there.
What do you mean by grade 1 copper?
So this is very, very high purity. This is like 99.99% copper, used for electronics fabrications and high quality research samples.
It's also used for electrical wiring. In fact, it's used so much that in a country like the UK, each person has about 175 kilos of copper associated with each person in the piping, the wiring and so on. The problem is that in many other countries, for example in China, people have very much less copper associated with them. There isn't so much electrical wiring in rural parts of China. And if everybody in China had the same amount of copper associated with them as those in England or America or Canada, there wouldn't be enough copper in all the known deposits around the world.
Copper is actually necessary for life. Plants and animals use copper. But actually you can have a disease called Wilson's disease, which basically your body can't metabolise copper properly. It's actually an inherited disease.
Okay. Ready? What's going on there is it's producing a lot of gas, so it's reacting to form a complex, and it's going from the potassium tartrate complex there to, well, it's producing carbon dioxide and oxygen. Mainly oxygen gas is being produced, which is why you're seeing the fizzing. And it's become copper oxide, cuprous oxide actually.
Copper is found as a metal lying around in various places in the world. I believe the name came from the island of Cyprus in the middle of the Mediterranean, but copper has always been known. Even in prehistoric times, people found small amounts of copper. But as we use more and more copper, people have had to dig deeper and deeper mines. The mine in Chile, where those very brave miners were entombed for more than 2 months and then rescued, was a copper mine. And to get the metal that we need, we're going to have to go deeper and deeper and deeper into the earth.
So what we've got in there now is cuprous oxide, so that's copper 1 oxide. And it's actually gone from what was a kind of clear, see-through, all right, it's got a colour on it, but see-through solution, to something that's very cloudy. So what we've got there is a precipitate of the copper oxide.
Copper is very good because it has very high thermal and electrical conductivity. What that means is that heat flows through it very well, and also electricity. If you make wires for electrical transmission out of copper, when the electricity goes through them, you get very much less heating than if you say made the metal than say if you made the wires out of iron. And all this heating is of course lost energy. You do even better if you made the wires out of silver, but silver's too expensive.
Okay. So let's see if we can change this reaction back. So at the moment, it started out as being about 50. It's now shot up to 63. I imagine it was even hotter than that when it originally changed colour. So we'll see if we can take it back. Pop that back in.
I actually bought this from the British Geological Survey, which is just down the road from here. Is it in Keyworth, I think? And I just saw this and it was a Christmas present from my husband and I picked it out. I just think it's just really cool, actually.
What did your husband think of getting that as a Christmas present?
He knows what I'm like, so he buys these things for me. He knows I'm a bit of a magpie. I like to collect shiny things, pretty things. So that's my copper.
So the colour's gradually changing. It's gone from orange and now kind of a murky yellow. You can see it's kind of green now. And again, a gradual change. It wasn't a sudden, spontaneous, straight back to being blue and see-through, clear. It's now we've got back to that kind of clear solution. And again, you can see on the stirrer bar all the bubbles of the oxygen, a little bit of CO2 forming on that.
Most organisms, you and me, use iron in our blood to transport oxygen. That's what makes our blood red. But in some sorts of crustacean, crabs and similar lobsters, they're different. They use copper. They use a compound called hemocyanin. It's a blue compound of copper. Cyan is some classical word for blue. So they really have blue blood. And these hemocyanin uses 2 atoms of copper in each molecule to transport the oxygen around the body of the crab or lobster. But it's not nearly as good as hemoglobin. So if you start running after a crab or lobster, it quickly gets tired compared to running after a rabbit or something like that, which can keep going faster than you can.